The moment I release, so as this surface is smooth, there's no friction anywhere. So this will shift towards left, no? This will shift towards left. So the total, and what happened to center of mass? Center of mass will not shift again. So I do get a position will be of like this. Where M1 will be at see things clearly, very important this is. Center of mass will not shift. In fact, M1 is got shifted. You can see from the diagram also. I'll move a little bit towards left. M2, the wedge got shifted towards left here. Then by the time this comes here, this will have maximum velocity. This will have velocity VR something, whatever be that, we are not bothered. So the block will be moving. Then as this M1 starts sliding up on it, the normal contact on the wedge will act towards right, and that will retard the motion. And finally, the wedge block system is a rough diagram. I may not be exactly keeping center of mass. I will not be exactly showing that. Okay, fine. So this is M1. It has come to instantaneous rest. Because of velocity, what will happen? The block M1 starts sliding up. As it starts sliding up, it's like the normal contact force. This will undergo retardation, and finally they come to instantaneous rest. Both M1 and M2 are at rest. Instantaneous rest. IR, I'll write it. Now again the block M1 will slide. Again, what is the thing? This will have maximum velocity. This will be VR. The block will come back to its original position. And see that center of mass will not shift. And there's a basic idea of the entire discussion. Okay, no? This is T equals 0. And finally, this is, let's say some time T. We'll do one thing. We'll write from that. This is T. Total time of oscillation will be 40, but it's not SHM. Again, there'll be a test. I think everyone is able to understand instantaneous rest here. Like that, it will continue its oscillations. So somehow what happened, if you can repeat the problem for this, the same thing will get repeated for other part. Any objections you have, you can object it. Let me clarify. Why VM towards left? See, normal contact will act towards left, no? Because of normal contact, it will accelerate. Due to acceleration, speed, the normal contact n sine theta will act here. Due to n sine theta, the wedge will move towards left, will accelerate. Due to acceleration, speed will increase. By the time this reaches here, that will be the maximum speed. Very next moment, the block starts sliding up. N sine theta will act towards right. It will undergo retardation. So therefore, this is the maximum speed I should permit. Okay, no. So let's calculate the time taken by the block to move from A to B. Now, what will happen to center of mass? I think we should have some clear discussions here. Net force on system along x-axis 0. As the net force is 0, delta xcm will not shift. Of course, the diagram I have drawn in such a way that center of mass shifting, but it will not shift. And that's why I'm writing the instruction here only. Delta xcm, center of mass will not shift. But it didn't ask anything shift in the particular thing. It directly asked the time period of oscillation. So let's get, how come these two time will be same? So what I am claiming is what time the block will take to move on the wedge from A to B, same time what happened the block will take to move from B to C. Is it possible?
Yes, sir. Symmetry. Directly we can.
Yeah, symmetry 37 degrees is there, no? So somehow if you can discuss the problem from first and second diagram, I think it'll be over. Okay, I think a nice plan has to be there. It's not that I'll see question, I'll start writing. First, what actually happens, what has to be done. Then let's get into the mathematics. Now we know laws of motion ideas. We take help of this. So let this be the, if you want to, you can draw only one wedge like this. This M1, this M2. Let the acceleration of this be A2, let this be AR, let this be theta. So what are the forces they'll be acting? N sine theta, this will be, if I resolve, A2, so I'll get into the writing equation. So N sine theta equal to M2 A2. With respect to which the block will slide down along the inclined plane. So therefore, what are the, if you want, you can write AR or horizontal force. Let me write it here now. What is the horizontal acceleration of the block? M1, it is M1. Okay. A1x. So can we use relative velocity formula? AR cos theta equal to A1x. Please do notice here A2. Why negative sign? Anything directed towards right, I'll take it positive. What is the acceleration of the wedge will be towards left. What is the acceleration of the block with respect to wedge? Let me write terms, it'll be easier. Acceleration okay, these are major equations. So based on this, n sine theta equal to m1 a1x. We know masters m1 m2. If you want directly, you can substitute and solve. Equating these two, so we'll get the relation between a2 and a1x. I'll substitute that, but I need one more. Okay, let me go for along y-axis. I'll start this one mg m1g. Now look at this one. m1g minus n cos theta equal to m1 a1y. What is a1y? Will be ar sine theta. Theta also we know. 0.82. I have to check it. I'll check whether answer is there or not. 0.5 seconds. Time taken to move from A to B. This I'll simplify it. Next part. A1x I'll eliminate. So AR cos theta minus A2. Solving, let me call this equation 1, 2, and 3. How many unknowns are there? We have unknown AR, N, and A2. And equating these two equations will get relation between. Let me write. It will be better. Between A2 and A1x also will get the equation. Of course, A1x may not be needed. Solving 1, 2, 3, 4, we'll get expression for N, A2, and AR. After getting A2 and AR, we'll get AR. After I got this much of answers, you have to check it. I got these answers. So once if I know AR, it is released from rational. So what is the distance covered by it? AB is equal to, what is the length AB? AB is equal to 1 meter. Zero point 5 seconds. So total time period will be 40. Somehow we should understand the rightmost diagrams what I give as a concept. Look at once. I ended up, I don't know answer, but I solved it now. I ended up with this much here. If you want, you can cross check later on. Okay, one thing what we should make clear. Is it SHM? No, it's only oscillatory motion. The block oscillatory motion and not an SHM. Not a SHM. This is very important. Okay. Yeah. Now I'll go to the next part. Next question.